what if the Earth's environment was a non-reducing one? Recent evidence points in that direction, raising questions of how organic molecules formed and casting doubt on the idea that the first cells on the planet were heterotrophs. More current proposals for prebiotic chemical experimentation in a non-reducing environment are based on alternative sources of free energy and organic molecules that would have preceded life. And these look quite different from those assumed by Oparin, Haldane, and Miller. So what if the first cells were not heterotrophs? What if they were autotrophs, as suggested by this alternative scenario? Well, first of all, evidence that the prebiotic Earth might in fact not have been a reducing Earth, but rather a non-reducing prebiotic Earth, comes from rocks like this piece of zircon that was dated to 4.4 billion years ago. That time period is during the Hadean Eon, beginning at the Earth's formation about 4.8 billion years ago. Definitive evidence of life goes back to 3.8 or maybe as far as 4.1 billion years ago, but geochemical analysis of these Australian zircon rocks suggest that their oxidation state is the same as that of rocks dating to much more recent times, well after life existed on Earth. This is the evidence that the early prebiotic Earth environment might have been non-reducing. So where then did the Earth get its organic molecules? Could they, or even complete living organisms, have come from outer space? The ideas may not be as crazy as they sound. As for panspermia defined here, scientists believe that life could indeed have formed elsewhere in the cosmos. Think of the funds spent looking for water on Mars and other planets, not to mention SETI, that's S-E-T-I, the search for extraterrestrial intelligence. Still, I wouldn't blame you for being incredulous. After all, you might ask, how could life have survived on a meteorite or an asteroid? On the other hand, such heavenly bodies could have brought organic molecules with them. For one thing, organic molecules may have been formed along with the Big Bang itself. They are part of the interstellar dust and are found on comets and the like, so anything is perhaps possible. But for now, let's look at more earthly origins, even on a non-reducing Earth. While tidal pool scenarios fit nicely with Oparin and Haldane's primordial soup model, the origin of organic molecules and replicating polymers in a non-reducing environment must have been quite different. Without a reducing environment, how might organic molecules have formed if not in tidal pools? And how would they have polymerized? Inherent in these questions is an assumption that these organic molecules still formed in redox reactions on Earth, and that their efficient polymerization is still possible on a non-reducing planet. Answers to these questions could be different localized environments that had high concentrations of inorganic molecules and a sufficient amount of free energy to convert them into organic molecules, and some kind of primordial catalysts, perhaps mineral clay surfaces. Remember that many of today's enzymes incorporate some of the same metals that were in those catalytic clays. Could metal ions, for example magnesium, manganese, iron, etc., that now serve as enzyme cofactors, be a legacy of those clays? Could they have catalyzed organic molecule synthesis and polymerization?